delay, I would now like to invite Dr. Ganesh Rathod from University of the Witwatersrand, Johannesburg. Ladies and gentlemen, the session chair for this session is Dr. Atul Mishra, Dean Academics, JC Bose University. Now we would like to invite Dr. Ganesh Rathod from University of Witwatersrand, Johannesburg to lead us into this next chapter of learning on the title Machine Learning Applications in Geological Mines. Over to you, sir.
Sir, please unmute yourself.
Hi, good morning, everyone. Is it visible?
Yes, sir.
Good morning.
Yes, sir, you are audible.
Am I audible?
Yes, sir.
Oh, okay. Can I start now? Can I start now?
Sure, sir.
Okay, thank you. Thank you very much, organizers, and for the very kind introduction. In this particular session, actually, I would like to speak on AI and ML applications. AI and ML applications in the management of gold tailings. So why these gold tailings and the this particular tailings management is important in today's time is because of the nature of the tailings actually. So I would like to give a little bit intro about the tailings. So these are huge structures, I would say the largest structures on the earth, built to store the waste slurry that is been generated after the mining operations are done. And they are much more likely to fail than normal
Sir,
water
sorry
dams.
to interrupt you.
Yes.
Sir, are you sharing some screen? It's not visible over here.
Oh.
Your voice
Okay.
is clearly audible, but the screen is not being shared.
Okay, okay. Just a minute.
Sir, उन्हें हमें co-host बनाना पड़ेगा ना?
It says sharing is not turned on. You can request sharing for this meeting.
Yes, sir, we are doing.
Is it now visible, my screen?
Sir, it's still not visible. Sir, have you shared the screen? It's not visible. Yes, sir, now it's visible. Sir, now it's
Okay.
visible.
Yeah.
Thank you
Okay.
so much,
Okay.
sir.
Thank you. Just give me a minute. Okay. Is it visible now?
Yes, sir, it is visible.
Okay. Okay. Thank you. So these are the sorry for the interruption on my side. Actually, I didn't notice that screen is not shared. So these are the largest structures on the Earth. It can go in the height can go in tens of meters, and the dimensions could go in kilometers actually. Okay, and these tailings, they are much more likely to fail than normal water dams, and the rate is almost more than 100 times. Okay. So this failure causes environmental disaster, loss of life, and huge economic damages. So that is the background actually, basically, for why we work on these tailings. So the statistics actually says that for water dams, the failure annual rate is around 0.01%, and for tailings dams, it is 1 to 2%. So the risk difference is almost 100 times. There are few disasters that recent disasters, I'd say. Uh, Major is 1994, and very recent is 2022 that happened in South Africa. One is Marisproot and Jagersfontein tailings dam. And there are few studies also we have done on both of these dams. I would like to speak a little bit on these dams at later stage. Okay. So these AI and ML applications in gold tailings, an overview I would like to give on that is how AI ML are being applied in gold tailing systems to address some of these pressing issues like safety, environmental, and operational challenges. Then these gold tailing facilities are among the largest engineered structures on the earth, and they are storing fine-grained waste materials. This material is basically a stone powder. This is not a clay or sand, but it's a grounded rock basically. So it possesses very different behavior than soils. So the scale, longevity, and societal consequences of failure make these tailings management a safety critical engineering discipline. And in this context, AIML is not presented as a disruptive replacement for engineering judgment, but as a powerful decision making tool, basically. So this includes tailings dam safety, liquefaction and stability, and monitoring systems, water and energy efficiency, and opportunities for value recovery in tailings. So this AI/ML is framed as a tool that learns patterns from the historical and real-time data, helping us to detect the subtle changes and introduce AI/ML applications in well-understood physical mechanisms, such as these pore pressure buildup, strength loss, and system instability. So why at a global scale, actually, this matters, gold tailings, is this represent the largest and longest lasting footprint of gold mining. And for every ounce of gold that we produce, vast quantities of finely ground waste material are generated and stored. Instead of now, we stop calling it as a waste material because these tailings, they do possess the remining potential. So it's just the byproduct of mining which has remining potentials. And these facilities pose significant safety risk as these historical tailings dams, failures that have resulted in loss of life, environmental damage, and long-term social and economic consequences. And beyond safety, tailings are central to the contemporary discussions on the environmental, social, and governance performance. So, and another one is the climate change. So, this climate change adds further complexity through more intense rainfall events and water management challenges. And this is one of the parameters that adds to the safety of tailings, because during such events, actually, the pore water pressure builds up and we won't have control over it. And from engineering perspective, these tailings are complex material with evolving properties influenced by mineralogy, deposition methods, consolidation, and the chemical processes. So this combination of scale, complexity, and consequence makes tailings management a defining challenge for the mining industry, basically. So this traditional gold mine tailings management approaches, basically there are core engineering methods, then field monitoring tools are there, then limitations and challenges, and need for complementary AI and ML tools, how we can use it actually. So traditional gold tailings management, it relies on the combination of geotechnical data, geotechnical investigations, then laboratory testing, numerical modeling, and field monitoring. We often use soil mechanics principles, empirical correlations, and constitutive models to assess the strength, deformation, and stability of tailings. Instrumentation and survey data, actually. These markers provides internal conditions and movements. So they are helpful. These methods have enabled the design and operation of thousands of tailings facilities worldwide and remain fundamental to responsible practice. But they often based on simplified assumptions. So that is the role where AI and ML could come in. And laboratory tests may not fully capture the in situ fabric or the stress paths, while numerical models require these idealized inputs. And monitoring data are frequently interpreted using fixed thresholds or manual review, which can miss subtle trends or the trend from the historical data that we could get using AI and ML. So the key limitations of conventional tailings are the data is sparse and noisy. It is based on the static assessments, then subjectivity and bias and complex nonlinear interactions. So despite actually we do have this advancement in particularly in computational facilities, this conventional tailings assessment faces persistent limitations that are increasingly difficult to ignore. Actually, we must consider it. Data from tailing facilities are often sparse, it is noisy and heterogeneous, making it challenging to draw confident conclusions from any single indicator. So there are a number of parameters that we can consider. And in addition to that, even if the data is available, that there are uncertainty in the data. One is the uncertainty in the data itself, and second is the uncertainty in the model that we use for the analysis of this data. So there are many assessments are static in nature, and providing a factor of safety or compliances check at a particular point in time, rather than actually assessing it in a continuously evolving risk form. So human interpretations introduce subjectivity and bias, particularly when engineers are faced with the large volumes of time series data from multiple sensors and complex interactions between deposition practices, water balance, weather events, and material behavior can produce non-linear responses that are not easily captured by simplified models. So now there are two types of uncertainties. One is the data, and second is the model itself. Some of the models they are not helping much in capturing the responses, particularly non-linear responses. To apply these AI tools, AI and ML tools in managing the gold tailings, so if we can understand this life cycle in a better way, that would actually help us in a better and efficient application of tools in managing these tailings. One is the life cycle that begins with the ore processing, where grinding and beneficiation determine the physical and chemical characteristics of the tailings. Then it progresses through the tailings generation and deposition, followed by long-term storage monitoring, its closure, and in some cases reprocessing also, because now the technology is changing fast and there is a remaining potential for that. And each stage, at all these stages actually, it generates a lot of data that presents distinct technical challenges that are well suited to data driven analysis. So for at all these stages, the data is generated and we need a tool, we need a machine to process that data in real time that would help us in managing the tailings. So during this ore processing, machine learning can be used to link mineralogy, grind size, and processing conditions to downstream the tailings behavior. In the transport and deposition phase, it can help to optimize the pumping systems, predict segregation, and support the deposition. During storage and operation, the focus actually shifts to monitoring and risk management, where large volumes of sensor and remote sensing data must be interpreted actually continuously in real time. And finally, during the closure and post-closure, this tool can assist in long-term performance prediction, landform stability assessment, and evaluation of remaining opportunities. So though remaining opportunities is a different domain, but the main concern is actually about the stability of tailings. What AI and machine learning mean for us basically is artificial intelligence and machine learning. They are best understood as advanced data analysis techniques that identify patterns, trends, and relationship between the complex data sets. And rather than relying on complexity and only the program rule, these models can learn from the historical examples to make the predictions or classifications. In gold tailings, this might involve actually the learning how combinations of pore water pressure, deformation, rainfall, and operational variables have historically preceded stable or unstable behavior. So this does not replace the physical laws of engineering, but it operates alongside them, offering probabilistic insights and early warnings that complement the deterministic analysis. And framing this AI in the way that helps the technology and position it as a natural evolution of tools that engineer, we already use it, and such as regression, optimization, and system identification. This is one of the major concerns in tailings, that is liquefaction. One is the nature of gold tailing, then is the loading and stress effects, then subtle precursors to failure and importance of risk management. If with the help of these tools, if we can get some information on all four of these, or almost 60% task is done. So this is tailings are one of the most critical structures, and the most critical failure mechanism in gold tailing facility, and is central to understanding the tailings dams risk. There is a static as well as dynamic loading, and due to which there would be static and dynamic pore water pressure development would be there, and that would lead to the effective stresses. Those are being, if they reduce to zero, then the whole matrix would behave like a liquid. And it is a little difficult to predict the liquefaction in tailings because of the material variability changes, complex stress paths, limited monitoring coverage, and need for advanced analytics. It is a heterogeneous material, means the particle size, a simple example is the particle size distribution. That particle size distribution itself varies from center of the tailings to the faces. Also, the consolidation, degree of consolidation is not constant from top to bottom, so it varies. So material is very heterogeneous, and predicting the liquefaction would be much complicated in tailings. And for augmented liquefaction and stability assessment, what could be done actually? So the data that is now collected at all stages, it could be classified. So AI and ML learning, using these tools, we can actually make our assessments and our predictions much more effective from the collective behavior of the multiple data sources over time. So this is not now only the 24-hour data or the 1 week data, but if the data would be actually collected over the longer period and the analysis could be done in real time, then then only the prediction has some meaning. Okay. Instead of working on a particular time mark, if the data is being processed for a longer time and in real time, then only it can make a difference in tailings management. So now what we generally do is we rely on the factor of safety. Now we have this data. So instead of only leaning towards relying only on the factor of safety, if this data is giving me if this data is capturing some trends and giving me opportunities to predict and also maintain some thresholds beyond which there would be markers that would be sent to the tailings management, and then then we can act on it to take proper actions immediately. This not only would stop, I won't say stop, but at the same time, it would give us opportunity to make something that would work, and the period for the failure could be increased. And prediction time, that also matters. It's not only the prediction just before few moments that won't really help. So we need a sufficient time to act on the predictions. And AI and ML actually from one of our running project, that data still actually we have yet to achieve the stage where the prediction time could be in few weeks. So for tailing of, sorry, it's already 6:33. AI for tailings dam safety monitoring. So data collection and monitoring, machine learning and pattern detection, and enhanced safety decision support. So if we can use the high frequency sensor data on pore pressure, deformation, and rainfall data, that would continuously monitor the tailings. So high frequency data is more important in this case because we can get rid of the anti-aliasing in that case, and a continuous data processing would be done more effectively. Through this data, definitely the pattern and the trend detection would be done in a much efficient way, and the enhanced safety decision support would be made available based on the first two. The smart monitoring systems and the data integration. This combines the traditional instrumentation with the emerging technologies such as satellite-based INSAR data, drones, and automated weather stations. This AIML plays a key role in integrating this diverse data source into a coherent picture of facility behavior. So this is one is AI and data fusion, then automated screening and interpretation and applications in gold tailings. So this smart monitoring adopts to variable climate effects impacting the gold tailings facilities internal response. Then water and energy optimization using AI. So this would be one of the another benefit of using AI, that water and energy that could be optimized. So AI for water recovery, because water is one of the main part in mining operations basically, and when it is been sent or when it is been transported from mine to the mine tailings, and energy use optimization and sustainability and tailings stability. So in all these three, AI and ML models would come as an effective tool. So reprocessing of tailings. So there are over the period, so the technology has been advanced, and the tailings which were constructed few years back, so maybe 50 years back, so they still have the minerals available in it, and this particular tool actually could help us in looking for the remining opportunities through these tools. Though although this is a completely a different topic,
Professor Ganesh ji,
which would yes.
very good morning.
Okay, I'd be concluding in 2 minutes.
Yeah. Please.
So AI supported tailings storage facilities, risk monitoring. So based on the historical data and the pattern recognition would be done, and from this the prediction models would be actually giving us the early warning systems actually would be developed for that. There would be enhanced situations for awareness that AI supports the timely informed decisions without making definitive failure predictions. Okay. The limitations, risk and responsible use of the AI. So data quality and governance, that it offers significant benefits. It also introduces the limitations and risks that must be managed responsibly. These models are not only good as the data to train them, making data quality and representativeness and the governance critical. Acknowledging these limitations is essential for maintaining the credibility and ensuring that AI is applied as part of the robust engineering rather than as a standalone solutions. And clear validation, documentation, and integration with existing management systems are key to the responsible adoption. Okay, let me skip this part. Okay. The future outlook for AI in gold tailings management is the digital twins for tailings. That integration of AI/ML into tailings management is expected to deepen through the development of digital twins, real-time risk dashboards, and autonomous monitoring systems. So at WITS, actually, we are working at developing a full-fledged station, a monitoring stations, which would be providing services to tailings management companies. These advances will enable the more holistic and continuous understanding of facility behavior across the entire life cycle, from design to its closure. Means from immediately from the beginning of mining to the closure of the mining, and also the tailings. So the tailings actually represent a critical safety and sustainability challenge. Liquefaction and stability are the central mechanisms driving risk, and AI/ML offers practical tools to enhance the understanding and decision making. When this has been attached properly, using the engineering principles, these data-driven methods can improve the early warning system, optimize operations, and support value recovery. The most effective applications emerge from collaboration between disciplines and a clear recognition of both capabilities and limitations of digital tools. By embracing this integrated approach, the engineering can contribute to safer, more sustainable, and more socially responsible gold tailings management. And thank you for this opportunity, and this is the place from where I belong to. Thank you very much. I will take few questions if there are any.
Thank you, sir, for your enlightening words.
Now it's time to hear from eminent speaker, Dr. Surendra Singh. He is the president of Belmont Scientific Incorporation, USA. He is a thermal science expert, specialization in chemical reactivity with a portfolio of self-developed instruments including FRTC and TRC.
I would request sir to share his
Thanks, Dr. Ganesh ji. Very, very thanks. Hello?
Yes, sir.
Yeah,
If there are any questions, I can take few of them.
yeah. So, very, very thanks to you. In short notice, you take so much pain for me. It's a
No, pleasure.
greatness for you. I am obliged. Thank you. Thanks a lot. So see you. अब कभी इंडिया आएगा तो जरूर मिलेगा. Thank you. और we invite on behalf of the university also.
Thank you very much.
Thank you. So our next speaker is Dr. S.K. Singh. So सिंह साहब बहुत बहुत नमस्कार आपको. Thank you joining. Thank you to taking the pain. In your busy schedule, you are here and waiting for your chance. I am sorry will not supposed to give the correct time. Thank you.
Now it's time to hear from an eminent speaker, Dr. S.K. Singh. He is the president of Belmont Scientific Incorporation, USA. He is a thermal science expert, specialization in chemical reactivity with a portfolio of self-developed instruments including FRTC and TRC.
I would request sir to share his valuable thoughts with us on the title Safety Audits for Lithium-Ion Batteries. Also, sir, I would request you to conclude the presentation in 15-20 minutes due to time constraint.
Can you guys see our slides?
Yes, sir.
Okay. So I'll thank you so much for giving me opportunity to present the work. And I'm going to talk today on the comprehensive approach to determine the safety of lithium-ion batteries. And before going there, I will give you some background about myself. I graduated from the Lucknow University, and then I went for master's to Kanpur University, and then I did my PhD from IIT Delhi in 1990. Then 91, I came to United States to do as a postdoc, and then since then I'm here in working in different positions at different companies. Most of my experience is in the industry. The company I founded in 2020 has two major fractions. One section is the battery research and testing. We do all the performance testing, safety testing, all kind of the abuse testing, thermal runaway characterization, gas analysis, volume of the gas. So full line of the thermal runaway characterization we do, and also we provide the testing in order to get the certification. Various batteries goes through the various very tough testing protocols because these lithium-ion batteries are hazardous, and also when they go to thermal runaway, they generate a lot of gas and the temperature. The other part of the business is process safety management, where we provide the chemical reactivity testing, emergency relief system design, and process hazard analysis. So PSM side. So I won't go in talk about PSM anything. I'll go on the battery, and since the time is less, so I will short it. The battery is actually, it stores the chemical energy and it converts into the electrical energy at the time of the need, and vice versa. It has three major parts: anode, cathode, and electrolyte. And anode and cathode are separated by a separator. So all the lithium-ion batteries, they use the lithium anode material, not all, but majority of them. And lithium compound could be lithium cobalt oxide, lithium nickel cobalt oxide. The short name is LCO, NMC, LiPF6, all that kind of that. And they are, when you charge the battery, they become unstable, and they can react with the oxygen, moisture available, and they can decompose at higher temperature. The electrolytes also, one of the key thing in these batteries, they use organic solvent. So electrolyte is mostly use LiPF6, but that is a solid, so it has to be dissolved in the solvent. And most of the lithium-ion batteries, they catch fire and generate most of the energy because of these electrolyte solvents, which are organic solvents. They do the oxidation process, means combustion process, and generate the heat. One of the thing need to be noticed that for lithium-ion batteries, it doesn't need any outside oxygen to combust, because these electrolyte carbonates, they have plenty of oxygen to do the combustion. So even though the batteries goes with various testing, I will give you the example of the most commonly used cylindrical cell in the electric car batteries and laptop computers, lot of laptop computers, and they have quite a few safety features built in there. So when you have a battery pack, each battery pack nowadays has a BMS system which manages the batteries. It does a really good job. But then at the cell level, so this is the cell here, which is called cylindrical, and they have a jelly roll inside, and they have a safety feature here. It's called the PT, positive thermal coefficient, PTC. What it does, basically, it's a polymer, and at certain temperature, it becomes non-conductive. So the batteries are protected from outside overcurrent. So that's the number one feature is there. Then at the second level feature is the separators. If any region the cell temperature reaches to a melting point of the separator, it's shut down, so there is no ionic transport from one side to other side. And then there is another safety feature is here, like red color you see, that one is called the CID, current interrupted device. So if any region the gas is generated inside the cell, this disconnects the positive and negative terminal of the battery. So now after CID is open, cell cannot be charged or discharged. So that's another level of the safety feature. If that also doesn't work or even worked, still if gas generation is there, then this vent open. This is the vent here, blue line piece, that is vent. So those are the safety features already built in to protect the battery from going things wrong inside as well as outside. But it's still the lithium-ion batteries goes to thermal runaway. And there are various certification safety standards are there. And a couple of them I will talk here, which are most common. One is the UN DOT 38.3. If you want to ship your battery for the transportation purpose, you have to go through the UN 38.3 certification. Okay, and then the other one is the UL, underwriter laboratory testing. They have few standards, and the most common is the 1642 and the UL 9540A. 1642 does all kind of the abuse testing, to see that how the batteries can behave. And these are the various certifications are there, and even I think there is one is the Indian standard, which is called AIS 048, and those are for the automotive batteries. So the tests are pretty much named same, but the protocols are different based on where those cells are going to be used, whether they are going to be used in a stationary device or whether those cells going to be used in transportation, electric car batteries, or BESS application, or utility applications, or data centers. So based on that kind of the risk they can go through, the tests are designed. So the standards are written based on that conditions. But this, for the transportation, UN has about 8 kind of the test, and pretty much all of those standards have these kind of the tests, but different protocols. So like altitude test, thermal test assessment, that you can heat the cell and see how it behaves, vibration test, shock test, external short circuit test, impact test, like you can drop the weight, or cell can be dropped from a particular height and see whether it catches fire or not. So all these tests here are given. You have to do that, and your batteries can vent, can smoke, but should not catch fire to pass. Okay, and there are certain number of the tests need to be done, and without this certification, no one can transport the battery anywhere in the world. And these are the main common tests. No matter what standards you have, almost pretty much similar kind of the test they do: electrical abuse test, mechanical abuse test, environmental test, and fire exposure test. All that kind of the test, all these batteries and battery packs has to go through. I'll go on the UL 9540A. These tests need to be done for the BESS application, like a storage device. The batteries where you use it for utilities, data centers, all these batteries and battery packs has to go through the UL 9540A. What it does basically, at first you have a test at the cell level. If you can pass the test at cell level, then you don't have to go through the battery pack level. And cell level test is that you heat the cell around 4 to 7 degrees C per minute from room temperature to all the way to 300 degrees C, or above the melting temperature of the separator. And cell can vent, cell can smoke, but it should not catch fire. That's the passing. If it does, then it fails. Then you have to do the testing on the battery pack level. So those are the UL tests are needed for batteries, all the BESS application, and also for the data centers, utilities, anywhere we have the storage device. So to evaluate the safety of the battery, these are the following parameters one has to determine. Okay, and they help to tell how safe your battery is, what should be, what battery can tolerate and what it cannot tolerate. That's what in terms of the thermal safety, these parameters need to be determined. Like at what temperature cell starts heating by itself, if it does, then what is the heating rates, and what the pressure rise rate or peak temperatures, and what the adiabatic temperature rise is, how much total heat is generated, how much amount of the gas is generated, what the composition of the gas is, when the separator shut down, when vent open, and when the voltage drops. All that information need to be done in order to evaluate the safety of the battery at the cell level. There are major 3 techniques all over the world are used. One is the DSC, differential scanning calorimeters. Most of the undergrad colleges and universities, they have that instrument. Okay, and this instrument is used for testing the battery material testing, not the cell level. But the cell level testing could be done using the accelerating rate calorimeter, fractional thermal runaway calorimeter. ARC is very useful for small batteries to find it out what the safety parameters are, including the heating rate and the total amount of the heat. But for the bigger cells, it is difficult, you know, and it does not captures all the energy. That's why the FTRC is developed. FTRC is the most accurate, is the method which measures the total amount of the heat most accurately. ARC does somewhere around 50 to 60% of the energy it captures, while FTRC techniques are being used. I will just go over very briefly. In the DSC, these are the small cell test cells are used, and they can hold up to 2000 psi. So you put your battery materials, raw material, charged material, electrolyte, and you heat it up and see how the thermal behavior of the material is. Okay. In this technique, you use about 2 to 20 milligrams of the material. It's a very small material. It's a very screening tool, and you know within 30 to 40 minutes of the test, you can learn a lot. For example, here you have two anode materials used. One is the graphite, which has higher surface area than the greener color one, and you can see that the total heat of reaction peak heights are higher for the red one than the green one. And although the peaks, number of the peaks are same, but the total amount of the energy is different. And that makes sense that when you are using higher surface area anode material, so you have a more surface to react and generate the heat. So this kind of the testing you can do at very small quantity, and in the lab scale you can make a coin cell, scratch the material and put it in DSC and get the data. So material level you can do. If you want to do at the material level as well as in the cell level, then accelerating rate calorimeter is used, where you can use from 200 milligrams to all the way up to 5 grams sample, depending on how much energy is there. This is the tube test holders where you can test in milligrams, like 200 milligrams to 500 milligrams quantity. And these are the bigger cells where you can use the material up to 1 to 2 grams. And these are the holders here where you can use the cylindrical cell and full cell level. You can put the full cell. This is for pouch cell. This is the closed test you can run where you can measure the pressure also along with the temperature. And these are the open test where you only measure the temperature. And you can see the DSC, the ARC test. There is a cathode material which is fully charged MCA material, 200 milliamp hour capacity. And what we did, we had 100% charge capacity, 95% charge capacity, 80% charge capacity. And you can see the reactivity has significantly reduced when we have 90% charge capacity. So this type of the information battery designer can use it, and they can restrict it to the level of the charge state and to make the battery safer. So that's how these testing data is used. Here you have a holder. You can put a battery inside and run the ARC test and get the total amount of the heat generated. And if you connect with the pressure transducer and close it, you can also measure the pressure, how much pressure has been generated. And these are very sophisticated instrument, accelerating rate calorimeters, and they can detect exotherms around 0.02 degrees C per minute. But still, they don't capture all the reactions. Here I am showing the temperature versus time and cell voltage versus time plot collected from the ARC data. And here you can see the cell has heated more than 600 degrees C per minute. Peak heating rates are there. And it has generated around 675 kilojoules of the energy. And these are the 5,000 milliamp hour cylindrical cells. And the same cell, we use it in the FTRC, fractional thermal runaway calorimeter, and we have got about 119 kilojoules of energy. What we do, this is the FTRC, this is the holder where we put the cell, and this is the ejecta tube. So all the energy coming out of the vent is absorbed here in the ejecta tube. So we measure FTRC also gives you the information that if you have a cylindrical cell, how much energy is coming out of the can and how much energy is going through the vent as a ejecta. So the battery pack designers, they use this information to do the thermal management of the battery, that how much energy they have to release from the can, and whatever the vented energy is, how they are going to manage it into the battery pack level. So they need that information. So these are the main safety features are needed for the battery pack designers. And I've summarized the data here. Since you have given me 15 minutes, I think I'll reach over there. I'll tell in brief that DSC is good in the total heat of reaction measurement at the material level. ARC is good in the onset temperature, vent open temperature, and smaller cells. It's the best technique. But for the bigger cells, we need the FTRC, or I haven't included here TRC, thermal runaway calorimeter, which we have developed in-house. We use it for capturing the onset temperature of the heating rate, heating rate of the cell, peak temperature of the cell, what the total amount of the heat is generated, how much gas is generated, and then we collect the gas and send it for analysis. And once we know the composition, then we do the flammability testing. All that is needed under the UL 95408. So I have summarized here that DSC is very good technique for the material level testing. Majority of the universities, they can do it in-house. They can make the coin cells. It's very inexpensive to make. A couple of $1,000 equipment, you buy it, you can make it, you can start making the coin cell. Then ARC is there. ARC is pretty expensive. It's about $150 to $400,000 range, and it's good at the material level as well as the cell level. And then FTRC is a very good technique to find it out how much total energy and what fraction of the energy coming through the vent and how what fraction is coming out of the can, so that you can have a cooling system design for the battery pack. So I conclude my talk here, and I'm open for questions if you guys have any. Hello.
Hello, S.K. Singh sir.
Yeah.
Thank you a lot. Your precious time that you devoted to us.
Not
Thanks
a
a lot.
problem. I went very fast, you know.
You have to ask. Yeah, there one question. You come over here. Aye. So, my friend Umesh Gupta ji asked. He is an expert of electrical. Basically, he is a senior vice president of BSS Yamuna Power Limited.
Oh, very nice.
Dr. Surendra Singh, namaskar. I am Umesh.
Namaste ji.
Actually, when we are talking about the lithium-ion batteries,
Yeah.
as you are already, I think, aware that BESS, battery energy storage systems, now in India we are going for that, and a lot of utilities, and not only in India and worldwide, distribution utilities are installing BESS. So my question, you were discussing basically mainly on safety audits related to lithium-ion batteries. My question is more on the operation side. See, when we are installing these batteries in India also, I would like to ask you that what precautions should a user or any utility which is using lithium-ion batteries should take care while they are operating and maintaining these batteries. One thing. And another thing is that, as I understand, most of the time these batteries are put to use for suitable for charging, discharging type of load or cycles. When we use in power sector, see for the substation auxiliary supply management, then how you see these batteries in comparison to the conventional batteries like lead acid or NiCad batteries. So, because you see a very cumbersome and difficult, you are talking about the battery management system, which is compulsory part of the lithium ion battery, which is not there in the this NiCad batteries, etc. Thank you.
Yeah. So the lithium-ion batteries, they need to go through specific testing before installation. As I mentioned, there are various organizations. I'll give you just one example. Let's say you want to use these lithium-ion batteries into the data center. Okay. So based on that, the testing need to be done. UL testing need to be conducted. UL 1642, where all kind of the abuse testing need to be done, and then we need to do the UL 9540A, where we want to see that when battery goes thermal runaway, first of all, it shouldn't go, and if it goes, then what kind of the gas and how much gas is going to come out, and then what the building structure is there. So we have to design the building based on the flammability study of those gases. So that's the one. As far as charge discharge usage, lithium ion battery, the beauty is that in lithium ion battery you put 100 पैसा आप डालिए और 99.9 पैसे की एनर्जी आपको मिल जाती है. All the other battery, for example, NiCad battery, the nickel cadmium batteries and nickel metal hydride battery, you put $1, you get back only 80 cents. 20 cents energy is lost, and lost as a heat actually. By lithium ion battery, you get 99.9% back. So you only lose 0.1% or even less than 0.1%. So it's a very efficient battery, and they are well built, and the testing has to be done at the cell level first. If you see that Ola was catching the fire and all that, they just did some shortcuts, and a lot of Chinese companies, they are making the batteries, they are not up to the level of the quality. So if the cells have been tested well, they last long. All these batteries which we are making for the electric car batteries, they're supposed to work for 10 years, but still the technology on the control system is not as good. BMS has improved in the last 10 years significantly, and it has reduced accidents a lot. So I hope I gave you the answer to your question. And if I'm not, please feel free to reach out to me, and I'll find time to give you to respond to you.
Thank you, sir, for your inspiring words.
You're welcome.
Now I
And
would
wish you all the best. And thank you for organizing it.
Thank you,
you,
sir.
sir.
Yeah.
Now I would request Professor Arvind Gupta to honor the session chair, Professor Atul Mishra, Dean Academics, GC Bose University.
Now we request Professor Arvind Gupta to honor Dr. Rajesh Singh, Vanasthali Vidyapith, for joining this session. With this, we have come up to the end of the plenary session 2.
We hope that you all must have gained valuable insights from this session. Thank you. Now, Industrial Conclave is the next session and it will start in a short while.
A very good morning to all our distinguished dignitaries, respected guests, esteemed speakers, and fellow students. Today, I, Rakshita,
And I, Rudraksh, stand here to address today's gathering, which is for Industrial Conclave as a part of 2 days international conference on trends and advances in mechanical engineering, TAME 2026.
it has been organized by a university's Department of Mechanical Engineering to address industrial challenges in Faridabad by using advanced mechanical engineering and sustainable technologies for a self-reliant future.
We are honored to have among us Head of Dean Student Welfare Association, Mr. Pradeep Dhimri sir, Chairman of Mechanical Engineering Department, Professor Arvind Gupta sir, Director of Balaji Educational Institution, Dr. Jagdish Chaudhary sir.
We warmly welcome all respected deans, chairpersons, esteemed panelists, faculty members, and dear students. Now we'd like to invite Professor Pradeep Dhimri sir and Professor Arvind Gupta sir to welcome our esteemed guests with saplings as a token of growth and new beginnings. We'd like to call upon Director Encon, Mr. Vishwa Mahindra sir, to come forward to receive the sapling.
Now we would like to call upon CMD of Bonnie Polymers Private Limited, Mr. Raj Bhatia sir, to accept the sapling.
Now we'd like to call upon Managing Director at KBS Certification Services Limited, Mr. Kaushal Goel sir. Now we'd like to call upon CMD of Bonnie Polymers Limited, Mr. Raj Bhatia sir, to accept the sapling. Now we'd like to call upon Sandhya ma'am and Jagdish Chaudhary sir to present the sapling to Raj Bhatia sir, CMD Boni Polymers Limited. We'd like to call upon Board Advisor and CSR Head, Victura Technologies Private Limited, Mr. Ajay Shomvanshi sir, to accept the sapling from Sandhya ma'am and Jagdish sir. Now we'd like to call upon Managing Director, KBS Certification Services Limited, Mr. Kaushal Goyal sir.
Now we'd like to invite Divya Jyoti ma'am and Surendra and we would like to call Indradeep Singh Oberoi sir, Honorary Secretary, the Institution of Engineers, Faridabad, and Managing Director, AD Global Synergies Private Limited, to accept the sapling as a token of gratitude. Now we would like to invite Divya Jyoti ma'am and Arvind Gupta sir to present a token of sapling to Arvind Gupta sir, MD of AR Enterprises. Ashish Bansal sir, sorry sir.
Now we'd like to call upon CA and General Secretary at Laghu Udyog Bharti, Mr. Manoj Rungta sir. Mr. Manoj Rungta sir. CA and General Secretary at Laghu Udyog Bharti to kindly accept the sapling. Now we'd like to call upon Corporate Advisor BYST Mr. Som Dua sir to accept the sapling from Pankaj Dua sir and Sandhya ma'am. Now we'd like to call upon Senior Vice President, Rajdhani CSCS Delhi, Mr. Umesh Gupta sir, to kindly accept the sapling from Sandhya ma'am and Arvind Gupta sir.
I'm sure today we will truly be enriched with insightful perspectives and knowledge across diverse topics as the conference proceeds.
Now we'd like to invite the moderators for the day, Head of Teen Student Welfare, Mr. Pradeep Timri sir, and Director of Balaji Educational Institution, Dr. Jagdish Chaudhary sir, to take over further proceedings for the day and welcome all the panelists to the stage.
A huge round of applause for all the panelists, please. Now may I request all the panelists to take the seats on the podium, please. I request all to please take their seats. Mr. Raj Bhatt, Mr. Ajay, Umesh Gupta ji, Kausal Goyal ji, I.S. Oberoi ji, Ashish Bansal ji, and Manoj Rungta ji, Som Dua ji. Please, all. So a warm welcome to all. I would request all the volunteers to please help with the mic here, whoever requires the mic. So welcome all. This industrial conclave has been arranged as a part of our international conference, which is being organized by Department of Mechanical Engineering. So a huge round of applause to Mechanical Engineering Department that they have thought that we should have a industrial conclave as part of this international conference. As is generally the case, most of the time it is focused around the academic discussions, but now we are very fortunate to have the doyens of Faridabad Industries with us. So welcome you all, sir, and we know that Faridabad is the major industrial hub of Haryana, and Faridabad along with Gurugram, they contribute to the 43% of the revenue of Haryana. Faridabad, which was developed as a post-independence industrial hub of Haryana, it has contributed to the Indian growth story as well as Haryana growth stories. So we are very fortunate that we are in the company of these industry doyens, and but we cannot say that we cannot wish away the challenges. There are many challenges, and the challenges are twofold. Challenges are because of the change in technology, and they are also with the international scenario, what is happening around. We know that in the world nowadays, there are more than 50 conflicting points where the conflict is going on. And industry, because it is also a part of our society, it cannot be isolated from those things. And then technology challenges are there. We are talking of dark factories, we are talking of AI, we are talking of ML, and so many things. So how the Faridabad industry is coping, and is there any scope of cooperation with the academy? And there has been a general perception that the industrial requirements and the engineers being produced by the academy, there is a gap. So there is a gap in technology, there is a gap in manpower skill and all these things. So what a better panel we could have. And may I request all the panelists to have their opening lines, because we have a huge panel and we have a very enlightened panel. So I would request everyone to please restrict their opening remarks within 4 to 5 minutes, and then we can open up it further. So at the outset, I would request Mr. Raj Bhatia ji to open up the debate with his opening remarks. I would request volunteers to help with the mic arrangement here, please.
Good morning, everybody. I think the program is running late and probably most of the members have left. I do believe that the program that they gave was, the topic is the same, it has not changed. It was how to maintain sustainability for industries in Faridabad. I do not know why did you want to address it, industries in Faridabad. I mean, we have a great spectre of industries, and now everything is globally done, not locally done. So looking at the nomenclature, I think we'll go around that. The challenges come around these natural resources with which the entire universe is made. हम हमेशा 5 तत्वों की बात करते हैं, उसमें आकाश, वायु, अग्नि, जल, पृथ्वी, ये सब चीज़ें आती हैं. हमारे चैलेंज भी उसके ही आसपास आते हैं. जब हम एनवायरनमेंट की बात करते हैं तो फरीदाबाद इंडस्ट्री फेसेस एनवायरमेंटल इश्यूज. उसको कैसे एड्रेस करना है, दैट इज़ वेरी बेसिक. हम पानी की बात करते हैं, वी फेल शॉर्टेजेस ऑफ वाटर, जिसकी वजह से हमारी प्रोडक्शन और वर्करों को पानी देने में प्रॉब्लम आती है. So we have to address around that also. When we call of fire and energy, we call of energy. Energy has become a big cost today, तो हमें उसके बारे में भी सोचना होगा. तो इस तरीके से अगर हम challenges को गिनते हैं, they are all around those 5 तत्व, and we have to find solutions around that only. This is a basic concept running from ages, on which are various mythologists or people who have been writing things. They have been asking कि इनका संतुलन होना बहुत आवश्यक है. इस संतुलन के बिना कहीं भी पृथ्वी में प्रलय आ सकती है. आप पानी की फ्यूरी देख लो, आप अग्नि की फ्यूरी देख लो, आप तूफान की फ्यूरी देख लो, आप कंक्रीट करते जा रहे जंगल उसकी देख लो. सो इको बैलेंस के अराउंड हमारी डेवलपमेंट चलती है, और उसी से इंडस्ट्रियल की ग्रोथ में एक हमारी तरक्की आती है. बिकॉज दीज आर द रिसोर्सेज ऑन विच वी हैव टू see how we conserve our cost. Now coming to the academia and the institution like YMCA, I'll call it JC Bose now, हमारे जो challenges हैं वो हैं कि we have to compete in cost with countries like China, where the technology is much higher than what we have. They are supposed to be the global manufacturing hub of the world. जो वो बना सकते हैं, जिस कॉस्ट पे वो बना सकते हैं, और आज की डेट में मैं कहूँगा क्वालिटी भी अच्छी बना सकते हैं, तो वाई नॉट वी होल्ड हैंड्स ऑफ दिस एरिया. Since you said it is around Faridabad, so let me tell you Faridabad, since I am also the president of Faridabad Industries Association, we have more than I think 20,000 small and micro industries. उनके चैलेंज बड़े इंडस्ट्री से काफ़ी ज़्यादा होते हैं, लेकिन उनको compete करना पड़ता है without any getting much increase or their survival. गवर्नमेंट जैसी मर्जी सपोर्ट कर ले, पर जैसे मान लो अभी recently we have seen labor cost has gone up. So here comes the solution, not only for big but for small also. How can an institution like JC, Bose or other universities come up with low cost automation, which is very important for us to bring down the cost, improve the productivity and improve the quality of the product. Now low cost automation I say कि अगर आप 3 या 4 वर्कर भी कम कर देते हैं low cost से और उसकी ROI निकाल लेते हैं कि उस return on investment पे वो अपना खर्चा निकाल ले, तो आगे के लिए the cost of labor, the cost of ESI, PF, gratuity, leave with wages, overtime, everything gets eliminated. तो इस टाइप की ग्रोथ जो है या इस टाइप की जो इनोवेशन है वी कैन गो एंड सी इन चाइनीज़ एग्जीबिशन. अब हमारे यहाँ रोबो बनाने वाली कंपनीज हैं 8-10 ही हैं, बट मोस्ट ऑफ देम आर इन मेडिकल, AI जनरेशन या उसके अंदर टाटा या 2-4 ऐसी और हैं जो बनाते हैं. बाकी इंडस्ट्री दे रिप्रेजेंट बिगर कंपनीज ऑफ यूरोप एंड ऑल दोस. नाउ चाइना हैज़ डेवलप्ड अ रोबो विच कैन कॉस्ट इवन एज लो एज 2.5 lakhs. अगर आप टॉय इंडस्ट्री में जाएं, हमारे किसी ने टॉय इंडस्ट्री लगाई है, ही हैज़ वेरी लेस मैन पावर, उससे रोबो लगा रखे, छोटे छोटे लगा रखे हैं, दे डू एवरी फंक्शन दैट दे आर सपोज टू डू. नो व्हाई कांट वी डू इट? हमारे यहाँ टैलेंट की कमी नहीं है. एनेबलमेंट में हमें थोड़ा सा सहयोग देना है, वो इंडस्ट्री लेवल पे हो, यूनिवर्सिटी लेवल पे हो या गवर्नमेंट के लेवल पे हो. वी शुड ट्राई टू जनरेट दैट काइंड ऑफ थिंग. Now when we want to increase the quality, fix the parameters and improve the productivity, we will have to go in for automation. That will again bring pressure on employment generation. Now for employment generation, we should equally plan while these jobs go away, what other jobs they can get into, because this is our national concern. We have to see how we take the dividend of the young General G, that how would they come up. They should also adopt to the change. हमारे यहाँ प्रॉब्लम ये है कि we do not change with the rate of change going outside our factory or outside our country. जो बदलाव है उसको हमें हमेशा मैच करना पड़ेगा कि मेरी फैक्ट्री के अंदर मैं ऐसे प्रोडक्शन करता हूँ, AI असिस्टेड मशीन से करता है, तो नेचुरली इज क्वालिटी इज बेटर, इज प्रोडक्टिविटी इज बेटर. तो वो चेंज अगर मैं नहीं करता हूँ तो आई विल बी लूजिंग माई बिजनेस इन टाइम टू कम. अगर दुनिया में कोई चेंजेस हो गए हैं और हमारा देश उसको अडॉप्ट नहीं करता, विल लूज आवर एज देयर ऑल्सो. सो दिस इज ए कॉन्टिन्यूस प्रोसेस विच institutions like academia and industry should put together with the support of the government, which I believe it is available at many sources, but we do not know what to do and how to do and the way forward for that. तो ये चीज़ों पे हमें फोकस करके चलना चाहिए to see that how we sustain ourselves in the time to come. That's what I would like to say.
Thank you. So now we have Mr. Som Duwaji, who is corporate advisor at BYST. Sir, you can take cues from whatever he has said, Raj Bhatia ji. And you can also add this MSME, because MSME is the largest, employer of this thing. And in case of India, that cannot be ignored. So talking of employability and then sustainability, how can we link, and what are your views on this thing?
Thank you very much. Talking from challenges point of view, मेरे 2-3 पॉइंट आएंगे अभी. एक तो ये तो रियलाइज़ हो गया है कि फॉर एनी इकोनॉमी टू फर्दर ग्रो एंड डेवलप, टेक्नोलॉजी इज अ मस्ट. Technology is a must. There is no option or alternative to that. That is point number 1. But to add value to technology, we need entrepreneurs. जब तक हम एंटरप्रेन्योरशिप के बारे में बात नहीं करेंगे, हम फुल एडवांटेज टेक्नोलॉजी का नहीं ले पाएंगे. मैं बीवास्ती से हूँ, हम एंटरप्रेन्योरशिप के डेवलपमेंट के बारे में बात करते हैं और एक्सपीरियंस से मैं कहता हूँ कि जॉब्स की प्रॉब्लम बड़ी सीरियस प्रॉब्लम्स है. हमारे यंगस्टर यहाँ जो बैठे हुए हैं एजुकेटेड, मैं उनके बिहाफ से बात करता हूँ कि अनलेस वी प्रमोट एंटरप्रेन्योरशिप टू क्रिएट मोर अपॉर्चुनिटीज़, टेक्नोलॉजी आल्सो क्रिएट्स अपॉर्चुनिटीज़. So we have to create opportunities, whether it is a technology or we as an industrialist or as an entrepreneur, and that is possible when we encourage entrepreneurship. बीएसटी में हमारा जो एक्सपीरियंस है, मेंटरिंग खासकर हमें बहुत हेल्प करती है, और ये अगर हम मेंटरिंग का भी एडवांटेज ले पाएँ इंडस्ट्री में, हाउ टू यूज़ द टेक्नोलॉजी, द एप्लीकेशन ऑफ टेक्नोलॉजी, चाहे वो एआई है, चाहे वो रोबोटिक है, जैसे अभी बात कर रहे हैं, इज़ इक्वली इम्पॉर्टेंट एज द टेक्नोलॉजी इटसेल्फ। तो वहाँ आके थोड़ा सा हमें गैप आता है, नज़र आता है। और थर्ड जो आपने पॉइंट बताया जॉब्स का, वो एक सीरियस मामला है। एग्रीकल्चर में टेक्नोलॉजी कैसे यूज़ हो सकती है ताकि जॉब, ये जो माइग्रेशन हो रही है विलेजेस से, वो नहीं हो। आपने खुद कहा अच्छे तरीके से कि ये हम रिसोर्सेज कैसे एफिशिएंटली यूज़ कर सकते हैं, उसमें टेक्नोलॉजी का क्या रोल है। तो एग्रीकल्चर के लिए टेक्नोलॉजी, डिजिटल टेक्नोलॉजी, ये एनर्जी ग्रीन टेक्नोलॉजी, वेस्ट मैनेजमेंट टेक्नोलॉजी, सारों के सारे को एंटरप्रेन्योरशिप के साथ मिला के करेंगे काम, तो मेरे ख्याल में हमारा एडवांटेज काफ़ी आएगा। थैंक यू वेरी मच।
ठीक। Sir, if you can add something to this, and again, whenever we are talking of some industry or something, the first thing that comes into mind of the people is that profit. And when we are talking of sustainability, sustainability requires that we should not only think of immediate profit, but long-term solutions. Like Faridabad is facing the problem of pollutions. We are also have the bad tag of living in a very polluted this thing. So how can we integrate this all in your views?
Yeah, thank you very much, and good morning, ladies and gentlemen. We have talked about so many challenges like pollutions, technologies, and as Bhatia ji says, balancing between the natural resources. But there is, as a CHRO of the industries, what we are facing, I will tell you that. In today's scenarios, the mostly problem is for skill. We are the facing problem of to search the skilled people, and since we are sitting in the premises of the academia, so we will talk about that. There is a huge gap between the requirement and the availability of the skill. There are technologies changes in the industries. Conventional machines are wiped out. Computerized, numerical, and latest technologies machines are industries in there. But unfortunately, in engineering institutes, the availability of such type of labs is not there. So this is the main challenge we are facing so far. As far as job concern, I don't think there is much problem in the jobs. But there is the problem of the right people on right job. So as a academia, this gap should be filled between the industry and academia. We should create such type of infrastructure in the institute, engineering college, where the latest technologies labs should be there, and this latest awareness technologies lecturer and professor should be there. So until unless we will not fill that gap, industry will face the problems and youngsters will face the problems for the job. So this is my opinion, and I thank you very much for this university calling here to me. Thank you very much.
Thank you. I think Mr. Raj Bhatia has got something to say. Yeah.
I just heard two things. I'll first take the later part of it. When we say we do not get the level of skill of the people that we need in the company, let it be very clarified what we should do with this kind of challenge. If the level of education does not provide you that, take it as an academic qualification that he is qualified, which is a social passport also. कि आप पढ़े लिखे हैं. Rest, we should have our own plans in every industry for training from cradle to grave. जैसे ही आपके यहाँ student आता है, don't expect him to create wonders or do not expect any employee to deliver what you want. The best part is on-job training or on-floor training or the kind of job that you want to give. Train them to your needs, get the delivery to your needs, and correct them and modify them to their needs. That's very important. One point I would like to touch, our Honorable Mehta Sahab also said on agriculture. Of course, it is a very big sector. It employs 55% of the workforce. But the sectoral growth, if it happens in the agriculture belt only, one, there will be no migration. Two, the cost of living will be down there. Three, they can work in flexible hours. We have a large of implements that we can make for farming and sowing and cutting. वो कहते हैं जी वो जला रहे पराली जला रहे हैं ये जला रहे हैं और we can teach them backward integration कि खाली टमाटर मत लगाओ, create sauce out of that. There is a lot of multinational chains also there. So these challenges should also be addressed along with the thinking, which Mehta Sahab rightly said कि we should create employment for. Sorry for the.
Thank you. So we can pass it to Ashish Bansalji. Sir, you can take it forward and you can add your perspective to this also.
Yes, I first of all thanks to Professor Arvind Gupta sir. उन्होंने हमें ये चांस दिया कि आपसे साथ बात कर सके. चैलेंज की सर बात करें, जो मुझे लगता है जो भी सर ने बताया कि हमें खुद ही वहाँ पे इंडस्ट्रियल ट्रेनिंग देनी चाहिए, बट मैं जो समझता हूँ ये काम हम लोगों ने इंडस्ट्री ने किया. उसके बाद वो एम्प्लॉय हमको ये कहता है कि सर आ गया मैं तो चला. इस तरह की प्रॉब्लम्स भी हम लोगों ने बहुत ज़्यादा फेस की है जी. और सेकेंडली मैं ये कहना चाहूँगा कि जो स्टूडेंट्स हैं डेली अगर अपने आप को थोड़ा सा जो अपने आप को अपग्रेड करें और हम अपनी इंडस्ट्री को उस लेवल पे भी लेके जा सकते हैं टेक्नोलॉजी को अडॉप्ट करके कि हम चाइना से भी सस्ता माल बना सकते हैं. क्योंकि मैंने कई जगह देखा हम अपनी इंडस्ट्री को ही अपग्रेड नहीं चलना चाहते कि हमारी एक ही बात चलती है जैसे चल रहा है चलने दे थोड़ा कोई बात नहीं चलने दे. हमको अपनी इंडस्ट्री को भी अपग्रेड करना होगा. वो टाइम चला गया जब फर्नेस ऑयल का ज़माना था. आज इलेक्ट्रिसिटी हर जगह अवेलेबल है. छत्तीसगढ़ में अगर आप जाएं, उड़ीसा साइड में जाएं, सब जनरेटर का नाम भी लोगों को नहीं पता है कि कोई जनरेटर नाम की चीज़ होती है. तो वहाँ पे पावर बैकअप इतना स्ट्रॉन्ग है. तो ये हमने अपने आप को अपग्रेड करने की ज़रूरत है. एवरी टाइम छोटे छोटे स्टेप एक बड़े चैलेंजेस को बढ़ावा देते हैं सर.
Thank you. So now we turn to IS Oberoi. Sir, your products are, related to waste management, and you are also associated with the Institution of Engineer. You are the chairman of Faridabad chapter. So both are very relevant to this theme of sustainability. So one poor, performance of Faridabad also has been the waste management. Wherever we go, we see a lot of, untreated waste and like this. And engineers. So engineers are, they are considered to be the problem solver. So what is your take on this? And if you could relate that to our theme of this conference, that is the advancement of, engineering.
Dr. Dimri, thank you very much. Thanks JC Bose University for inviting me. coming to your question, I would just like to collaborate what thoughts I have in mind and come on to the points which you raised, sir. First of all, Faridabad was called Manchester of India. We had wonderful industries in Faridabad. Of late, what has happened, policies, government policies, movement of industries, migration, power backup, all those sorts of challenges were there which Faridabad industries had to go. My thought process is slightly different. Talking of Faridabad, we have the capacity and entrepreneurship in the industrial level also. I'm not talking about the students at the moment. Only thing is, and they are aware also what is to be done. The difference is the implementation of the awareness. मुझे पता है मुझे क्या करना है, लेकिन उसको कैसे कार्यान्वित करना है, उसको कैसे लेके जाना है, उसमें एक ब्रेक है. एज ए इंडस्ट्रियलिस्ट हम ये सोचते हैं शायद ये टेक्नोलॉजी या एआई मॉडलिंग या स्मार्ट मैन्युफैक्चरिंग है तो अच्छी, मुझे हेल्प करेगी, लेकिन उसका स्टेप जो है शायद मेरे कैपिटल एक्सपेंडिचर को बढ़ाएगा, मेरे केपेक्स इंडस्ट्री को बढ़ाएगा. In that case, what I feel is that institutions like JC Bose, academia, they should have a split-on module wherein an industry can progressively develop their skills to reach the level which we are talking about. Talking about the waste management, sir, we are working in space of wastewater for quite some time, and जो मैंने प्रॉब्लम देखी है, हम लोग रिलाई कर लेते हैं सर गवर्नमेंट इंफ्रास्ट्रक्चर पे. अगर मेरी इंडस्ट्री से कोई वेस्ट वाटर निकल रहा है, मैं उसको रीयूज़ नहीं कर पा रहा हूँ, मैं सीधा एसटीपी प्लांट पे भेज रहा हूँ. गवर्नमेंट इंफ्रास्ट्रक्चर इज़ वेरी लिमिटेड. वी कांट एक्सपेक्ट वंडर्स फ्रॉम द गवर्नमेंट इंफ्रास्ट्रक्चर. तो हम लोग काम कर रहे हैं डिसेंट्रलाइजिंग ऑफ द वेस्ट ट्रीटमेंट, कि मेरी अपनी इंडस्ट्री है, मेरा अपना हाउस होल्ड है, मैं उसी में ही ट्रीट करूँ with a very cost effective module, और उसी पानी को मैं यूज़ करूँ, उसी चीज़ को मैं रीयूज़ करूँ. So that we are trying to work out, and we've got wonderful support from industry, from MCF. We've been talking to the administrator of MCF कि आप वेस्ट वाटर को डिसेंट्रलाइज करिए. सीधा एक बड़ा प्लांट बनाने से फ़ायदा नहीं होगा, क्योंकि सारा वेस्ट जा रहा है, और फिर जो हमारी कैपेसिटी आज बनी हुई है, चाहे हम सीवरेज की देखें, फ्लडिंग हो जाती है. फिर जब मानसून आता है, फॉर ऑल सिटीज़ गेट्स फ्लडेड. रीज़न इज़ वी वर डिज़ाइंड 40 years before. We have not upgraded the system. So we should reduce our dependency on those systems, and we need to evolve that system. That was one part of it. Second was just skill की बात करी. And I have opportunity to work as a chairman of Institution of Engineers India. और IEI एक ऐसी प्रोफेशनल बॉडी है जो कि इंजीनियर्स की प्रोफेशनल बॉडी है, जो वी डायरेक्टली आर कनेक्टेड विद द एकेडेमिया एंड इंडस्ट्री. वी आर अ ब्रिज बिटवीन एकेडेमिया. सो वी डू कन्वेंशंस, वी डू सेमिनार्स, वी डू वाइट पेपर्स. Incidentally, abhi once we were talking about the skills for the students out here, the students are there. Institution of Engineers India has come up with a level 6 course of NCVET, जो कि नेशनल काउंसिल ऑफ वोकेशनल एजुकेशन ट्रेनिंग है. तो हम लोग जो ग्रेजुएट इंजीनियर्स हैं उनके लिए कोर्सेज डिज़ाइन कर रहे हैं, जो कोर्सेज कमेंसरेट विद द रिक्वायरमेंट ऑफ द इंडस्ट्री ऑफ पर्टिकुलर रीजन. जैसे अगर हम उड़ीसा की बात करें सर, तो वी आर डिज़ाइनिंग कोर्सेज फॉर माइनिंग इंडस्ट्री. सिमिलरली अगर हम होसूर की बात करें तमिलनाडु में, तो हम मैन्युफैक्चरिंग इंडस्ट्री की बात कर रहे हैं. सो उसमें हम लोग इवन हैदराबाद में वी हैव एक फैसिलिटी है, अगर इफ मोस्ट ऑफ द पीपल शुड नो, इंजीनियरिंग स्टाफ कॉलेज ऑफ इंडिया. दैट्स अ मोस्ट मॉडर्न इंस्टीट्यूशन विच इंस्टीट्यूशन ऑफ इंजीनियर्स हैज़. तो हम लोग उसमें बैटरी के ऊपर नए कोर्सेज जो आजकल सॉलिड स्टेट बैटरीज और ईवी बैटरीज है उस पर कर रहे हैं. सो पर्पजली ये है कि आई जस्ट क्लोज डाउन. 3 चीज़ें हैं. पहला है वी शुड वर्क टूवर्ड्स अचीविंग परफेक्शन स्लोली. सेकेंड इज सस्टेनेबिलिटी, अपनी चीज़ खुद कैसे साफ करनी है, यूज़ करनी है. एंड थर्ड इज इंडिजीनियस वर्किंग, अपने स्किल्स को डेवलप करना. दैट्स माय पॉइंट सर. थैंक यू.
So talking of sustainability and how can we ignore the energy, and Umesh Gupta ji, sir. You have been associated at the policy making of energy, and there was a time when more than 95% of energy was produced by the coal, from the coal. And now I suppose there have been changes and alternate fuel, and we are talking of solar and alternate fuel and all these things. So a lot of things are going on in the energy sector. And because you have been associated in the planning and the policy implementation, so what could you add to this perspective? And of course, energy is greatly related to sustainability also. Yeah.
Thank you, Dr. Sahab. And first of all, I would like to congratulate JC Bose University for organizing such a wonderful conference, especially involving the industry of the Faridabad. When I was a student at Aligarh University, there was a conference on energy, this Industry Institute Relationship, IIR. So I take this conference like that, one of that conference. And then on the subject, first I would like to discuss the topic from where Raj Saab has left, the change. Change, as I understand, perceive, is a continuous process. परिवर्तन सृष्टि का नियम है और होता ही रहता है. उस चेंज को परसीव करना, इट इज़ वेरी इम्पॉर्टेंट. एंड उस चेंज के साथ में हमें भी बदलाव लाना, ये बहुत इम्पॉर्टेंट है. मे बी टेक्नोलॉजी है, मे बी ह्यूमन स्किल्स हैं, ये सब हम बात कर ही रहे थे. एंड मे बी एनर्जी sector also. Everywhere it is there. We have to understand it. जहाँ तक इंडस्ट्री का सवाल है, चेंजेस का, इसमें जो परिवर्तन है, मेरा समझ है कि हमें ये समझना होगा कि ये जो चेंजेस हैं कॉन्टिन्यूस होना चाहिए. यू कैन नॉट चेंज समथिंग ड्रास्टिकली. धीरे धीरे करके आप चेंज लाएंगे तो आई थिंक इट विल बी अ गुड थिंग. दूसरा, चेंज करने के लिए हमारा माइंडसेट क्या है. जनरली अभी जो देखने में आ रहा है, थोड़ा सा बात चाइना की भी हम लोग कर रहे थे. इन इंडियन इंडस्ट्री व्हाट वी सी इज जनरली, अर्लियर आई वाज टॉकिंग टू सिंह साहब, कि हम क्या कर रहे हैं, बहुत ज़्यादा ट्रेडिंग इस तरह का कुछ करते रहते हैं. सो रादर देन सजेशन, आई वुड लाइक टू रिक्वेस्ट कि हम इंडस्ट्री में हमें ये कोशिश करना चाहिए कि हमारी जो टीम्स हैं, स्पेशली यू सी देयर आर वेरी नाइस टूल्स ऑल्सो फॉर चेंजेस इन द ह्यूमन बिहेवियर, लाइक SGA, स्मॉल ग्रुप एक्टिविटी करके रहता है, विच आई थिंक मोस्ट ऑफ अस नो. ज़्यादातर हमें अपनी इंडस्ट्री में इस तरह के रहना चाहिए कि सब सभी जितने भी काम करने वाले हमारे हैं, वो किसी ना किसी ग्रुप के मेंबर हैं और वो उन कंटिन्यूसली जो चेंजेस हो रहे हैं उनको समझें. एंड व्हाट दे आर डूइंग, दे शुड आल्सो अंडरस्टैंड दैट प्रोडक्ट, दैट प्रोसेस क्लियरली. अगर उनको हम समझ पाएंगे ढंग से तो उनमें जैसा हम चाह रहे हैं बदलाव ला पाएंगे अकॉर्डिंग टू द टाइम. अगर वो हमें समझ नहीं है तो बहुत सारी गलतियां होंगी और उस गलती की वजह से ना तो प्रोडक्टिविटी इम्प्रूव होगी, ना ही प्रोडक्ट की या सर्विसेज की क्वालिटी इम्प्रूव होगी. सो व्हेन वी से चेंज, क्वालिटी एंड प्रोडक्टिविटी, ये बहुत दो इम्पॉर्टेंट चीज़ें जिनको कि हमें समझना चाहिए ये कैसे आने वाली हैं. और उसके लिए जो हमारे काम करने वाले लोग हैं उनका स्किल सेट, एंड आई थिंक दिस इज़ ए वंडरफुल प्लेटफॉर्म फॉर दैट ऑल्सो. कि अच्छा है कि एक इंडस्ट्री का इंस्टीट्यूट के साथ रिलेशन बने, एंड दैट शुड बी ए कॉन्टीन्यूस रिलेशन. आई वुड लाइक टू रिक्वेस्ट सम फोरम इस तरह की क्रिएट हों जहाँ पर कि हमारी जो इंडस्ट्री है उससे जो प्रॉब्लम्स हैं वो प्रॉब्लम्स इंस्टीट्यूट तक आएँ और इंस्टीट्यूट अपने साथ में काम करके उन पे कैसे काम कर सकता है। आई थिंक गवर्नमेंट को भी पॉलिसी की बात हो रही थी, उसमें भी रोल प्ले कर सकता है इंस्टीट्यूट, क्योंकि कई बार क्या होता है कि इंडस्ट्री इन इटसेल्फ प्रॉब्लम्स को फेस कर रही होती है, बट उनके पास बहुत ज़्यादा गवर्नमेंट से मे बी ड्यू टू मैनी रीजंस वी ऑल अंडरस्टैंड कि वो ज़्यादा चेंजेस नहीं आ पाते पॉलिसीज़ में, बट एक प्रोमिनेंट यूनिवर्सिटी इंस्टीट्यूट अगर इस चीज़ को लेकर के आगे चलेगा तो आई थिंक दैट विल बी ए बेटर थिंग, तो वो हम एक कर सकते हैं। दूसरा एक बहुत ज़रूरी बात है कि थोड़ा सा बात राज साहब भी कर रहे थे उसकी, कि हमारे जो स्टूडेंट्स हैं स्पेशली व्हेन वी आर सिटिंग हियर इन द यूनिवर्सिटी, हमारे बहुत सारे सुनने वाले स्टूडेंट्स भी हैं, उनके लिए भी बड़ा इम्पॉर्टेंट है कि ये बेसिक्स हैं कि अभी क्या हो रहा है ट्रेंड के अपनी जो कोर सब्जेक्ट है उसको छोड़ करके और इंस्टीट्यूट्स में या जो भी स्टूडेंट्स हैं वो लगे रहते हैं कि कोडिंग को जाएंगे, इसको करेंगे। वेदर यू आस्क मैकेनिकल इंजीनियर, वेदर यू आर इलेक्ट्रिकल इंजीनियर, वो सब उसी पे लगे रहते हैं। तो मेरा रिक्वेस्ट है, बिकॉज कई बार हम उनसे भी इंटरेक्ट करते रहते हैं, अल्टीमेटली योर कोर सब्जेक्ट पेस यू बेटर इन लेटर स्टेज। तो आप अपना जो कोर सब्जेक्ट है उसको ज़रूर समझने की कोशिश करें। अदरवाइज क्या होता है कि जब भी कहीं भी जाते हैं, एम्प्लॉयबिलिटी की बात हो रही थी, अगर आपको अपने कोर सब्जेक्ट का ही समझ नहीं आ रही ढंग से तो आप बहुत ज़्यादा नहीं कर पाएंगे। दो इंडस्ट्री विल ट्रेन यू, वो आपको जब पहुंचेंगे तो अकॉर्डिंगली अपने रिक्वायरमेंट के हिसाब से ट्रेन कर देंगे, लेकिन हमारे लिए चैलेंजिंग ये है कि हम अपने कोर सब्जेक्ट को तो समझें, तो इस तरह के हम कर पाएंगे तो मुझे लगता है कि ये एक अच्छा इनिशिएटिव होगा। एंड जो हमारा ऑब्जेक्टिव्स है ऑफ सच कॉन्फ्रेंसेस, दोज ऑब्जेक्टिव्स विल आल्सो बी अचीव्ड। एंड देन कमिंग टू द मेन थिंग विच यू आर आस्किंग अबाउट द इलेक्ट्रिकल एनर्जी, यस चेंजेस आर देयर, एंड मैं थोड़ा शॉर्ट में उसको करता हूँ क्योंकि काफ़ी समय मैंने ले लिया। व्हाट इज़ हैपनिंग दैट ट्रांजिशन, जैसे मैं कह रहा था चेंजेस हो रहे हैं, तो ट्रांजिशन इन एनर्जी इज ऑल्सो गोइंग देयर। सबके पीछे एक मूल भावना है जिसको राज साहब ने भी शुरू में इंडिकेट किया, वॉट एवर चेंजेस वी आर गोइंग टू डू, अल्टीमेटली वी नीड टू नो दैट इट शुड नॉट डिस्टर्ब द बैलेंस इन द नेचर। जो तीन हमारे मूलभूत रिक्वायरमेंट हैं, जल, वायु और जमीन, सॉइल, हाँ, सॉइल वाटर एंड एयर, इसको डिस्टरबेंस नहीं होना है किसी भी हालत में। तो ऑब्वियसली एनर्जी सेक्टर में जहाँ कोल की बात आ रही थी, अभी तो 90% से ऊपर चल रहा था, अभी हमारी डिस्ट्रीब्यूशन कंपनी भी इस तरफ जा रही है कि 50% रिन्यूएबल एनर्जी से बिजली लें, तो ये सब चेंजेस आ रहे हैं। एंड वी हैव ए बिगेस्ट फोरम फॉर दैट, इंटरनेशनल सोलर अलायंस। हमारे माननीय प्रधानमंत्री जी ने पूरे विश्व को सोलर अलायंस के साथ जोड़ा है और उस तरह की ये बिजली की भी आ रही है। सो दैट इज़ ऑल्सो ए आई थिंक प्लेटफॉर्म फॉर द इंडस्ट्री ऑफ द फरीदाबाद, कि हम उस तरफ भी काम कर सकते हैं कि अपना जो भी हम बिजली की खपत करते हैं, बिजली की ज़रूरत रहती है, तो सोलर पैनल्स को लगा करके आजकल उसके लिए पॉलिसी गवर्नमेंट की तरफ से है, तो हम उस पर क्या कर रहे हैं वो भी ध्यान कर सकते हैं। ये चेंज तो आने वाला ही है और लगातार आएगा, क्या हम कर सकते हैं बेटर, दिस इज़ इम्पॉर्टेंट। तो मैंने कुछ जो बातें कही कि हमें अपने, जी जी जी, हाँ नहीं बिल्कुल आप ठीक कह रहे हैं। हाँ हाँ, मैं उस पर आपके सवाल पर दूँ। पहला वाला सवाल आपका, सोलर के केस में थोड़ी सी एक समस्या है। एक तो आप देख ही रहे होंगे कि सोलर का अपना एक साइकिल रहता है वेदर के हिसाब से। So you don't have continuous electrical energy or energy available from the solar plants. So उसके लिए आपको कुछ ना कुछ बैकअप तैयारी करनी रहती है, और वो चल रहा है, वो चल रहा है. इसको यूज करिए.
So what I mean to say is कि जैसे हम 5 तत्वों की बात करते हैं, they all can generate energy for you. We have never harnessed the water. फॉल तो हमने ले लिए वाटर के, बट वेव्स एनर्जी हमने कभी हार्नेस नहीं करी. सी वेव्स ऑल अराउंड होती हैं एंड देयर लॉट ऑफ सोर्स. सो हियर आर द गैप्स ऑफ टेक्नोलॉजी वेयर वी नीड टू वर्क ऑन. सोलर एनर्जी से ज़्यादा तो और कोई हमारे पास सोर्स हो भी नहीं सकता करने के लिए जिसको आप चाहते हैं. सो डैट मीन्स आई नीड स्टोरेज बैटरीज डेवलपमेंट दैट इट कैन गिव यू एनर्जी राउंड द क्लॉक. ठीक है ना. तो जब हम इन चीज़ों को जब देखते हैं कि हम पहाड़ों से थोड़े थोड़े पानी बहते हैं, there are other sources of waterfalls where you can have low cost generations also for the people to use on those things. And we should not always go in for high composite materials or all those things. जितने भी हमारे पास इस environment के अंदर blades हैं या leaf blades हैं, they can also work out if you can improve on their technology. So resources बहुत हैं. जैसे आप कहते हैं जी यहाँ से वहाँ नहर जानी है, ब्रिज नहीं है, कैसे जाएं? But there are routes available which can form a very strong bridge from coming from this side to that side. So these are the things that we should work on the university levels and try to see how we can use natural resources in a country which is not very rich, still developing, but how can we develop further within the available resources.
बिल्कुल आप ठीक कह रहे हैं. ये ट्रांजिशन का फेस है एंड दीज चेंजेस विल कम इन ड्यू कोर्स ऑफ टाइम. वो आने ही हैं. सोलर के साथ कुछ इस तरह की हैं जिन पे अभी टेक्नोलॉजी पे काम चल रहा है स्टोरेज का, सो दैट वी कंटिन्यूसली गेट द पावर. साइकिल के जो रहता है सोलर का, दिन में मिलती है, रात को नहीं मिलती, वो है. एंड नॉट ओनली दैट, व्हेन यू इंटीग्रेट इट इनटू द पावर ग्रिड, जब आप उसको पावर ग्रिड में इंटीग्रेट करते हैं, जहाँ तक अपने यूज के लिए है वो आप कर सकते हैं, लेकिन जैसे ही आप इंटीग्रेट करने लगते हैं ग्रिड से, देन देयर आर इश्यूज़ क्या, जैसे हम बात कर रहे हैं कि पॉल्यूशन की, तो क्योंकि आप देख रहे हैं कि जो ये अपना सोलर से बिजली अपने को मिलती है, उसको फर्स्ट यू हैव ए डीसी, देन यू कन्वर्ट इट टू एसी, देन वी टॉक अबाउट द पॉल्यूशन ऑफ द electricity through these systems also, because you use solid state devices, so many things are there. उन पर भी काम चल रहा है. एंड नॉट ओनली दैट, क्या होता है कि सोलर में आपको कन्वेंशनल एनर्जीज की तरह से इनर्शिया तो कुछ होता नहीं है, तो फॉल्ट कैसे, प्रोटेक्शन सिस्टम्स कैसे काम करेंगे. देयर आर लॉट ऑफ थिंग्स. दोज हु आर ऑफ इलेक्ट्रिकल इंजीनियरिंग, दे मे अंडरस्टैंड दैट इट्स टेक्नोलॉजीज आर स्टिल evolving, that how to go for the integration of the such solar energy into the grid more and more. And definitely there are people are working on it, engineers are working on it, and in due course of time ये सब आएगा रास्ता. लेकिन अभी धीरे धीरे करके आ रहा है. अभी आप सोचिए कि अभी भी हमारे इंडिया में आई थिंक सोलर लगभग कैपेसिटी देखें तो इट्स ह्यूज, बट अभी 20% के आसपास हमारा लगभग ये आया है रिन्यूएबल एनर्जीज में. अभी कन्वेंशनल एनर्जी बहुत ज़्यादा है, बट टाइम इज़ नॉट फार अवे कि ये सब चीज़ें आएंगी. दूसरा जो आप पूछ रहे थे, दूसरा सवाल था क्या? हाँ, बाकी के जो और रिसोर्सेज हैं, जो और जिनसे आप बिजली की बात कर रहे हैं, हाँ, उनमें सब में क्या है कि स्केल, कितने स्केल पे आप उसको कर पाते हैं कन्वर्ट करके बिजली में, दैट इज़ चैलेंज, रियली चैलेंज. सी में टेक्नोलॉजी इवॉल्व हो रही है, ये सब चल रहा है, बट हो सकता है कुछ समय में, अभी आप देख ही रहे हैं कि ऑयल के ऊपर डिपेंडेंसी ख़त्म करने की बात चल रही है, तो टाइम है कि ये सब चीज़ें आएंगी. बट अपने जो चेंजेस आ रहे हैं टेक्नोलॉजी में, वो भी चैलेंजेस थ्रो करते हैं. चेंजेस, लिथियम आयन की बात हो रही थी, लिथियम आयन से इंजीनियरिंग इंस्टीट्यूट्स के लिए बड़ा चैलेंज होगा, उसको कैसे डिस्पोज ऑफ करेंगे, क्या करेंगे बाद में, ये अपने आप में दिक्कतें आएंगी. सो चेंजेस आर देयर. जैसे मैंने कहा कि चेंजेस को समझ के करना अच्छा रहेगा कि वो हमारे जो पॉल्यूशन ना करें, एयर, वाटर एंड सॉइल, ये सब ध्यान रखना पड़ेगा, एंड चेंजेस विल बी देयर, वी हैव टू एक्सेप्ट इट, अकॉर्डिंगली वी हैव टू मूव इट. Thank you.
Interesting. So now we turn to Kausal Goyal ji. And sir, you have been associated with the certification. And there is a lot of talk about skill and its certification. So is everything going well there, or do we need some policy inputs in that case also? And our university actually, Raj Kumar ji knows that it was established keeping this in mind, that it will be highly producing the skilled manager who will be fulfilling the needs of this industrial house. And now a lot of other universities are emulating that this thing. So do we need to look at that aspect also? Yeah, please.
Yeah, thank you. First, I will start with the subject where we were discussing about the sustainability. And a lot of discussion has been on the sustainable products. So it's not about the product quality now we are talking about. We are talking about the sustainable component also with the product. And that, where to find that it is sustainable or not, how to find it. There is the certification which takes place actually, which makes sure that the product is really sustainable or not. Because there is a lot of confusion about what is sustainable or what is not sustainable. So for that we have to understand the background of this. Like we know all that there is a global warming we are talking about every day. And worldwide there is an agreement that if we don't address these issues like the global warming, the earth is going for a catastrophe. Because at the pace which the temperature is increasing in the atmosphere, which already has increased to 1.5 degree from the 1990 level, and if the pace goes like this, the increase will be more than 2 degrees Celsius by the end of this century. And if that goes, then the almost one third of the earth will be underwater. So to address this, there is an agreement, Paris Agreement, and in all that countries have committed certain things, and India has also committed that by 2070 we will go make our country as the net zero. And for making net zero, we all have a role, and industry has a very big role in that. That we reduce our emissions, we make sure that we use the resources sustainably. Sustainably, what means? Sustainability is that you can address your current needs by making sure that your future generation is not affected. That is sustainable, which is not impacting, like हमने जिन 5 तत्व की बात की, that is not impacting those in any negatively. So that is the concept. Now coming to the education part and the students, I will suggest mechanical energy or whatever the stream we are talking about, it's not now isolated. Earlier we are using reading mechanical energy and environmental science differently. But now environmental science is a subject for everyone. Whether you are in computer science, whether you are in mechanical, electrical, everything. Nobody can be left out of it. So you make sure that students learn this environmental science, sustainability concepts, they understand it, how they make the product as sustainable, which we were talking in the various presentation also, which was going on before we started this panel discussion. So for that, there are concepts that how you will make sure that the product is sustainable, so you have to understand the various concepts. What is the life cycle of a product? In the life cycle of the product, what are the impacts that can create on the atmosphere, on the environment, air, soil, water uses. So you have to understand those concepts. What is the embedded carbon of your product? How is going to impact the global warming? So all these concepts needs to be understood, and it is needed also because sustainable product is not a choice now that you cannot make that it's optional. It's mandatory. Even if your product is good, your price is good, but for companies are going now for sustainable procurements also. They are evaluating your product based on the sustainable index, and they are prioritizing those procurement which are more sustainable than the regular products. So we have to understand all these concepts. We have to make sure that product, whatever we are creating, they are not impacting the environment in any negative form. So now for all the students, which I will prefer, like earlier as were saying that everybody is now used to study the coding and the computer science, even if the stream was different. But the time has come that even although we are talking like, for example, AI also is a good tool, but there also is concern about the energy uses there. The GPUs, the amount of energy they use actually has a very threat to the environment again. So we have to understand that as for engineers now, it's rather than the AI, computer science, it's more important now. Rather, I'm not against the computer science, but I'm saying that it's more important everyone to understand the environment concept and sustainability more, and make sure that wherever you go, you implement it. Again, I would like to also address one point here for the industries, that industries also need to implement the concept why the certification is required. Most of the, I'm not putting it negatively, but my experience is, because I am into this industry since almost 25 years now in the certification of the organization, we take it as a certificate, as a piece of paper, which is required. No, this is not the requirement actually. What you need to do is you have to implement it. You have to, if you want to increase your efficiency, if you want to increase the quality of your product, so you have to implement the systems which are made by international expert with the best of the practices they understand. So you have to actually implement those in the real spirit actually. Not just purchase a piece of paper, because you can purchase a piece of paper today as a certificate to meet the today's requirement, but actually you are lagging behind in the competition. And that is where India is actually also facing the problem. Like Government of India, our Prime Minister Modi ji has started a very good concept, zero effect defect, JAD certification. Government is paying a lot of subsidies on those. But again, I have seen that industries are going just mere for certification rather than implementing them in spirit. So we have to implement it. Now there are a lot of new requirements, I think, for particularly I would say, which is connected to the mechanical engineering also, and our industry in Faridabad, which is mostly in the automobile sector, and related associate ancillaries, that like Europe, for example, they have come out with a CBAM requirement. So whatever export you have to do there, you have to declare your carbon emissions or embedded carbon of the product. So until that cannot be done by simply purchasing a certificate, you have to really implement it, otherwise you are going to pay a very huge tax for it. So with all this, I thank you. Yeah.
Thank you. Last but not the least, Manoj Rungta ji, you have been associated with Laghu Udyog Bharati, and एक focus area जो लघु उद्योग भारती का है, to find the स्वदेशी alternatives, and NEP 2020 which greatly talks about कि जो अपनी traditional Indian traditional knowledge है, how that can be, because that will be beneficial for all, because उसकी जो भावना है सर्वे भवन्तु सुखिना वाली, without excessive focus on the profit, it talks about the welfare of all. तो लघु उद्योग भारती कितना इसमें कर पाई है, या क्या योजनाएं हैं, या क्या किस तरह से आप कर सकते हैं, और सस्टेनेबल फ्यूचर के लिए हम क्या कर पा रहे हैं, यदि आप इस पे प्रकाश.
Thank you, sir. Thank you for inviting me. Laghu Udyog Bharati, I will say the organization is basically working for the welfare of the small scale industries, micro small industries, and we are a pan-India basis organization, and around more than 65,000 plus members we have pan-India basis. So before coming to your question, the most of the panelists, what the challenges they discuss is basically skill set disparity between the industry demand and the academicians students what they get. So for the addressing this disparity and this challenge, what Laghu Udyog Bharati has come up with is associating with the academicians, academics universities. We have done around 50-60 MOUs with the industry universities. What we basically doing in that MOU, we are looking after their courses and what are the industry requirements. We are bridging those gaps in between the syllabuses. वी आर एडवाइजिंग यूनिवर्सिटीज़ कि आप ये वाले कोर्सेज लाओ, ये स्किल सेट उसमें आने चाहिए, सो डेट जब बच्चे निकल के बाहर जाते हैं तो दे मस्ट बी एम्प्लॉयबल. आज प्रॉब्लम व्हाट प्रॉब्लम वी आर नॉर्मली स्टूडेंट्स आर फेसिंग व्हेन दे गो इनटू द मार्केट, दे आर नॉट ट्रेन्ड, दे आर नॉट एम्प्लॉयबल. आपने पढ़ के आगे नॉलेज है बट दे डोंट हैव द स्किल सेट, जिसको हम बोलते हैं कि भाई नॉलेज तो है लेकिन स्किल सेट नहीं है, सो इंडस्ट्री में नहीं एम्प्लॉयबल हो सकते. सो वी आर हेल्पिंग ऑन दैट एरिया ऑल्सो. वी आर ट्राइंग टू गिव देम द ऑन जॉब ट्रेनिंग. वी आर मेकिंग MOU विद द यूनिवर्सिटीज. उनके जो बच्चे हैं उनको अपनी इंडस्ट्री में हम फ्लोट करते हैं कि दीज आर द स्किल सेट ऑफ द स्टूडेंट्स and whoever have the demand, they can employ them as a trainee for the timing, and then once the on-job training is done, then that can be shifted to a permanent job also. This is how we are doing. Coming to सर्वे भवन्तु सुखिनः, लघु उद्योग भारती का तो ध्येय ही यही है कि सर्वे भवन्तु सुखिनः, सभी का सुख, सभी का भला चाहते हैं. तो वी ऑल्सो प्रमोट कि भाई प्रॉफिट भी लेनी है. हमने ऐसा नहीं कि हम व्हेन वी आर इनटू बिजनेस, वी आर मैन्युफैक्चरिंग समथिंग, वी मस्ट जनरेट प्रॉफिट, बट प्रॉफिट इतना नहीं होना चाहिए कि वो किसी के मतलब पूरे दम निकाल के हो. इंडस्ट्री अगर प्रॉफिट ले रही तो एक सस्टेनेबल प्रॉफिट जिसको बोल सकते हैं कि यस, इट शुड बी अ सस्टेनेबल प्रॉफिट वेयर यू डोंट चार्ज हेवीली ऑन योर प्रोडक्ट्स. दिस काइंड ऑफ प्रमोशन वी आर डूइंग इन आवर मेंबर्स. And regarding the challenges, other challenges what we see is basically in mechanical terms कि automation की जो problem है, not the labor problem is there. जैसे बंसल जी ने भी बोला, आपने बताया कि there will be a huge shortage of labor. So industry has to go into automation and the automation cost has to come down. So इसमें academicians के तरफ से ही हो सकता है, they must research on the automation कि sustainable automation, low cost automation, how we can provide to the industry so that the industry can adopt those automation quickly and faster. This is what the requirement of the today. Thank you.
Thank you very much, Manoj ji. The true wealth of a nation is its healthy and wealthy citizens. और इस healthy और wealthy citizen के लिए हम लोग फरीदाबाद को जब देखते हैं तो लगता है एक बार तो शायद दुनिया की सबसे अच्छी जगह हो सकती है, लेकिन जब एनवायरमेंटल की डायमेंशन से देखते हैं तो लगता है दुनिया की सबसे बुरी जगह है, क्योंकि यहाँ पॉल्यूशन की छुट्टियाँ होती हैं. तो ये जो सस्टेनेबिलिटी की बात हुई, सबसे पहला तो मैं कॉन्ग्रेचुलेट करता हूँ ऑर्गेनाइजर्स को, अरविंद सर को और इनकी पूरी टीम को, यूनिवर्सिटी को भी, क्योंकि बच्चों को उन लोगों के सामने बिठाया है कि जो इनकी भविष्य की जो सफलता की यात्रा है वो ऐसे ही होके जानी है, इन लोगों के थ्रू होके जानी है. और इन लोगों ने जो अभी एक्सपीरियंस अपने शेयर किया, या यूँ कहिए जो हमारा मार्गदर्शन किया है, इन बच्चों के लिए ये ना केवल काउंसलिंग जैसा है बल्कि एक फ्यूचर के लिए तैयारी जैसा हो रहा है. आगे के ये 2 या 4 साल के बाद आप लोगों ने इसी रास्ते से चलना भी है. तो सबसे पहले तो हम लोगों के फरीदाबाद की जो इंडस्ट्री की जो डायमेंशंस हैं वो कौन कौन सी हैं, हमें ये भी जानने को मिला. दूसरा कि इसके अंदर जो चैलेंजेज हैं वो कौन कौन से हो सकते हैं, और बहुत सारे ऐसे एरिया जिसमें कि हम लोग अपना फ्यूचर और अच्छे से कर सकते हैं. और एक इसमें जो स्टेटमेंट थी कि हम लोग एंटरप्रेन्योर बनने की जो बात है, क्योंकि वो होता है जो भारत को मजबूत बनाता है या भारत को भारत बनाता है. तो आप सभी लोग अपने आप को एक मैन पावर की तरह ना लेकर एक जॉब प्रोवाइडर बनने की दिशा में यदि काम करते हैं तो ज़्यादा अच्छा है. और नेक्स्ट के आप लोग जो अभी एकेडमिक वर्ल्ड में हैं, इसमें बहुत अच्छा है कि YMC तो एक प्रीमियर इंस्टीट्यूशन है, तो ट्रेनिंग भी आपको बहुत अच्छे से देता है. लेकिन उसके बावजूद भी कहीं ना कहीं कुछ यदि गैप रहता है तो आप लोग अभी उसकी तैयारी कर लें, क्योंकि समझदार व्यक्ति वो होता है जो कल की तैयारी को लेकर आज से अपना शुरू कर लेता है कि मुझे किस डायरेक्शन में जाना है, ताकि बाद में लेट ना हो जाए. तो इन सब लोगों ने उस डायरेक्शन में हमारे लिए बहुत अच्छा रास्ता दिखाया है, और मैं आप सबको थैंक यू करता हूँ कि आप लोगों ने समय निकाला, और आप लोगों से भी कि जो कुछ आज यहाँ से लिया है उसके लिए तैयारी करें, ताकि इन लोगों का आना भी सार्थक हो और इस कॉन्फ्रेंस का मिशन भी पूरा हो. प्रदीप जी,
अगर एक दो किसी के मन में कोई जिज्ञासा है, कोई प्रश्न है तो वो पूछ सकते हैं, क्योंकि दिस पैनल ऑफ एक्सपर्ट्स वुड नॉट बी अवेलेबल ऑल द टाइम. सो प्लीज़, अगर कोई Mostly I would encourage the students to ask.
Hello. Yes.
नहीं, मैं मैडम की बात में 2 लाइन ऐड कर देता हूँ और अच्छे से, ताकि हमारे यूथ भी इस बात को समझ ले। देखिए, फरीदाबाद में एक ऐसा कुछ इंटरनल नेक्सस ज़रूर है, इस पर थोड़ा सोचने की ज़रूरत है कि दुनिया के सबसे बड़े हॉस्पिटल हमारे फरीदाबाद में क्यों खुल रहे हैं। आप लोग एक छोटी सी इन्वेस्टमेंट करते तो बड़ा सोचते हैं कि प्रॉफिट होगा कि नहीं, चलेगा कि नहीं। आप लोगों के यहाँ एशिया का सबसे बड़ा प्राइवेट हॉस्पिटल खुल जाता है। और मैं आपको बता दूं कि एक जो मेट्रो हॉस्पिटल था वो हार्ट के लिए खुला था, लेकिन अब उसने अपने कैंसर का स्पेशल और बिल्डिंग बनाया। आप लोगों के माँ अमृता हॉस्पिटल ने कैंसर का बड़ा बड़ा बोर्ड होर्डिंग पूरे मार्केट में लगाया। और आप लोगों को मालूम है कि 40-45 हज़ार नहीं, 65,000 कैंसर पेशेंट फरीदाबाद में हैं। क्योंकि हमारे पास, जैसे अभी इन्होंने 3 एयर वाटर सॉइल की बात की, तो हमारा जो वाटर है, यमुना को अब यमुना रिवर नहीं कह सकते, यमुना नाला हो गया है। आपका आगरा कैनाल है, आगरा नाला हो गया, वो भी केमिकल वेस्ट प्योरली। आपके जो गुड़गांव कैनाल है, गौची ड्रेन है, वो सब केमिकल हैं। और इस वजह से उसके आसपास जो एयर भी है वो भी कहीं ना कहीं, और जो सॉइल है, तो मैं तो कहता हूँ इलेक्ट्रोप्लेटिंग जोन में चले जाएं जेसीबी के पीछे, वहाँ की सॉइल को हाथ लगा देंगे तो भी हमको कैंसर हो सकता है, इतना इचिंग होगा। तो यहाँ सिर्फ इतना ही कहना है कि जो सस्टेनेबल प्रॉफिट, कितना अच्छा शब्द आपने बोला है। तो हम फरीदाबाद के लोग, क्योंकि राज से केवल अपेक्षा ना करें, जैसा आपने कहा, समाज को भी मिलके चलना पड़ेगा, अपनी रिस्पॉन्सिबिलिटी लेनी पड़ेगी। तो कहीं ना कहीं शायद हम उसमें पीछे रह गए हैं। तो केवल एक शब्द और भी होता है, जो इविल इज टेम्पटेटिव बाय नेचर। जो इविल होता है, जो बुराई होती है ना, वो बहुत आकर्षक लगती है। ज़्यादा पैसा कमाना है, लालच भी एक बुराई है। और शायद कहीं उसकी नज़र तो हम लोगों को नहीं लग गई फरीदाबाद को, ऐसा भी हो सकता है। तो प्लीज़ सर, इस पे थोड़ा सी बात रखें कि बैलेंस कैसे हो।
your point is very valid, and you opened a secret which is known to all of us. I would not say that today Faridabad industry is making enormous profits. I speak on behalf of industry also. The industry is working on wafer thin margins. मनी मेकिंग कोई और चीज़ें कर रही हैं, कोई और इंडस्ट्री कर रही है, जैसे साहब ने बोला नए हॉस्पिटल्स खुल रहे हैं, वो एक अलग इकोसिस्टम है. टॉकिंग अबाउट our relevance as an industry in the pollution, yes, that is a very, very, very valid question. Each industrialist, each citizen of India should ponder upon. जैसे मैंने अपना जब once I was talking about, I talk about the waste water treatment. I have ventured into hinterlands of India, जहाँ पर शौचालय नहीं है सर, और क्योंकि अब स्वच्छ भारत अभियान मोदी जी ने किया है और फेज़ 1 हो चुका है, फेज़ 2 जा रहा है, टॉयलेट्स तो बिल्ट अप हो गए हैं सर, पर निकासी नहीं है. And that is a major problem of groundwater pollution. So we are educating small households to develop. We are guiding them, we are giving them a very cost effective system. जिसे एक हाउसहोल्ड अगर 5 लोगों के परिवार है, 10 लोगों का परिवार है, वो अपना वेस्ट खुद मैनेज करे, rather than dumping onto the mother earth. वेस्ट मैनेज करके उस वेस्ट को रीयूज़ कैसे करना, उसका वेस्ट वाटर कैसे रीयूज़ करना. वी आर ट्राइंग टू एजुकेट ऑन दैट, क्योंकि आपको ये बात भी समझनी पड़ेगी कि सस्टेनेबिलिटी जो बज़ वर्ड है, ये लास्ट 5-10 साल में ही एक्टिवेट हुआ है, उससे पहले सब चल रहा था. तो अभी एक सोच आई है, and I'm confident, and even government of India is very, very confident and working towards this direction with the direction of Prime Minister. And I think we are going into that direction. Yes, lacunas are there, and obviously systems are being developed, but that will take time, some time. We are requesting the universities, people like you who have been into the research, to guide the industry if they have certain problems. We at Institution of Engineers India, like I told you, we get problems from the industries also. So we come back to the dashboard of these institutions. So yes, the things are being developed. It is a problem, but I think solutions are being taken care of, sir.
Thank you. So time has already.
Like to add one point here, because she asked about whether it's the government policy which has the solutions or the citizens which has to come forward. Actually, it's the both way. Like, see, government can be only enabler. Like, for example, they have given us choice whether we adopt the EV vehicles or we go for the fossil fuel. So we have to understand which is more sustainable, which is more environment friendly. Whether we adopt the solar, they can come up with the policies like they give the subsidies and everything and promote it. But ultimately it's the consumer citizens who has to adopt it. So as an industry also we have to see, because this Faridabad has not mean bad. We are now saying that Faridabad is environment is not good and all this. Who made it actually? We people who are residing in the Faridabad city. Not the government. I would say government we can always blame. It is easy for us also too. But whether we are putting our duty or we are following our responsibilities, how we are disposing our waste from the industries, whether it is not impacting any environment, how we are using the water, whether we are using in our household or energy, whatever it is. So it's all, we are people who are actually responsible for it. Government can come out with some policy level to some direction, but ultimately we have to do that. Thank you.
Very true. We have already run out of time. I would only end with the actually quote of Harishankar Parasai ji. I don't remember it exactly. लेकिन उनका एक कोट था कि पिछले महीने मेरे शहर में 1 राशन की, 2 पान की, 3 मेडिकल की और 4 शराब की दुकानें खुली हैं. ये और एक भी जो है किताब की दुकान नहीं खुली है. ये मेरे समाज का दर्पण. So we are responsible for that also. Thank you.
So thank you all, basically all panelists and participants, and we special thanks to Pankaj Ahuja ji, BUST pupils, and other one, and all panelists on very short notice, all are agreed to over here, to come over here. So I thanks from my heart to become over here and be the part of this events. So thank you to all. Basically, the problem is from civil society itself, not from the industry itself. We are not very much aware. We are running with the thin margins, but still we are polluting a lot. That is the problem. Basically, we are not using the appropriate technology and appropriate use. Both things are responsible. It is not from one side. So thank you to all. So, आप सभी चाय के लिए.
This has been a platform for intellectual enrichment, bringing together distinguished speakers, researchers, and participants from diverse domains. Now we'd like to call Dr. Arvind Gupta sir to honor our moderators. First, we'd like to call Mr. Pradeep Timri sir to accept the token of thanks. Next, we would like to call Dr. Jagdish Chaudhary sir to accept the token of thanks. As the conference ends, we would like to extend a heartfelt gratitude to our reputed panelists for sharing their valuable time, knowledge, and perspectives with us. We would like to request all the guests, faculty, as well as participants to proceed towards MMC for the tea break. Thank you.